So we start off with this note that says we need equations in the proper form before we can solve. And as I said, that's a lot of what this lesson is going to be about. We start with an equation that's a bit messier, and so we need to do some work and simplify it and put it in the right form before we can solve. But then solving is always the same. We're going to check the discriminant, b squared minus 4ac, and decide whether we need the quadratic formula or we can factor. What do we mean by proper form? Well, it's either going to look like this: ax squared plus bx plus c equals 0, where a, b, and c are real numbers. They could be decimals, they could be fractions, they could be integers. There's your typical trinomial. We like a to be positive, because if I'm going to factor, I haven't done a lot of practice factoring with a, the first term, having a negative value. If a was -3, that whole process of writing, like the little thing we do off to the side where we write out the factors and we cross multiply and add them together, that kind of thing, that's different if a is not positive, if a is negative, if it was -3 or whatever. So I can make it positive when it's an equation, so that's not a problem. But that's something to be aware of. Okay? Usually a is positive, but it doesn't have to be. If you're doing quadratic formula, it doesn't make a difference if a is positive or not. The other case that we might see is when c is 0, there is no constant, and we just have the x squared and the x term. And this is the case where you always common factor. And I've mentioned this many times. Whoops. I was writing fraction or something. Factor. Common factor. I've mentioned many times that for whatever reason, lots of people miss it and they just don't see it and they find this one hard to do. But once it clicks for you that if the constant is missing, the c is missing, and there's just two x terms, that you can always just common factor out an x. Once you get that, then these ones become trivial, right? They become really easy. It's the same every time. So watch for that. And then the other case, which is the exception. So notice that for those two cases, everything is on the left and it's equal to 0. That's the key idea that we're talking about here. That way, either I can use a quadratic formula, and for the quadratic formula, it has to be equal to 0. You can't have a bunch of junk on the other side. Or for factoring, I need it equal to 0 to use the zero product property. It's the only way that this works, right? Learning goal we just took up, we talked about that. You can't be equal to 14. It's got to be equal to 0. So you have to move everything over. The one exception is this. C, or maybe negative c you would call it. But if you're missing the middle term, the x squared term, or just the x term, ax squared minus c equals 0, something like that. Okay, one of those two, it's the same thing. You just move the c over to the other side. In this case, you might have a difference of squares, and so you could factor it and solve it that way, or you might not. Either way, you could also isolate. This is the one exception where we don't have to, you might anyway, but you don't have to move everything to the left and set it equal to 0. Okay? And after you've simplified and done all the work and cleaned everything up, those are the only three cases. You have all three of the terms, x squared, x, and the constant. You only have the x squared and the x, or you only have the x squared and the constant. If you don't have the x squared term, I think I mentioned this the other day, it's not a quadratic. So it's a different kind of equation. And what we're talking about right now is quadratics. All right. You know what? Solve each quadratic equation. I'm going to take out the by factoring part because, for one, just in general, I don't really see why it would be there. Even if they are all factorable, there might be cases where you don't notice that it's factorable. But there actually happens to be an example that's not factorable, so it doesn't make any sense to solve by factoring. On the test, there will be a section that says solve by factoring. In that section, they will all be factorable, okay? That's not going to be a trick. There might also be a section, solve using the quadratic formula. And so it tells you right off the bat that you have to use the quadratic formula. But then there will be a bigger section probably that just says solve. And you can solve however you like. But if it's factorable, you should factor. It'll save you time. Some of them won't be factorable. So that will be the part where, like the last lesson on Friday, you have to decide, probably using the discriminant, which way is the best way to solve, and solve it that way, right? And so that's kind of what this question we should approach it that way. Let's see if they are factorable. If they are, we'll factor them. If not, we'll have to use the quadratic formula. So what do we do in this case? Well, we got to expand the brackets and clean it up and get it into that form that we were just talking about, right? And probably move everything to the left, set it equal to 0, and then decide what to do next. So we've seen this before, where we're expanding those brackets. And these brackets. Okay, there we go. It should be 5x. So now we'll move everything to the left. And you don't have to write it out this way or show this, but I'm going to subtract 15 from both sides. And I am going to subtract 5x from both sides. So I get 2x squared. 6x minus 5x is x. And there's nothing to subtract 15 from. So it's like 0 minus 15. So just negative 15. And everything's gone from the right side. And we're left with the trinomial. There it is, cleaned up. 3 terms equal to 0. That's what we're looking for. On my calculator, I'm going to do b squared minus 4ac. b is 1, right? The coefficient of the x term. So in this case, it's 1. A is 2. C is negative 15. I think we kind of get that by now. And it should work out, I believe, to 121. Did anybody check that? That's what you got. Very good. Therefore, we can factor. So you might choose to write out all of the factors, all the pairs of factors. You would do 1 and 2, 2 and 1. This is what the list should look like. 1 and 15, and 3 and 5. Those are the only numbers that multiply to 15. Okay, and 2 is prime, so there's only one pair of numbers. And I flipped those. That would be your list. But as I've said before, when one of them is prime and the other one only has 2 factors, I usually just throw in the 2 and the 1 And in this case, I'm going to guess that it's 3 and 5. And sure enough, 2 times 3 is 6. And 5 times 1 is 5. And 6 minus 5 is 1, which is what I'm looking for. Okay, and then I have to decide, is the 6 positive or is the 5 positive? The 6 should be positive because the middle term is positive 1. So I want it to be 2 times positive 3 and negative 5 times 1. Negative 5 times 3 is negative 15. So I think we're good. Okay. Equals 0. Therefore, and you can set each bracket equal to 0 individually and solve, but if you've done a bunch of these, you get to the point where you can kind of do that in your head and save that step, and it's fine to just write out the solution. If it's also fine to show that step. And when it's a fraction answer, you don't want to make the mistake and get it wrong. You don't want it to be 2 over 5. People do that because they're trying to take shortcuts, and I guess they haven't practiced enough of these to be able to do it correctly in their head. But it's going to be the 5 moves over and becomes positive, and then divide both sides by 2. That's how you get 5 over 2. But like I say, if you can do that in your head, you don't have to show that step. But of course, it's fine. Good? So that we've seen a question like that that has brackets in it already, but you want to distribute the brackets, move everything over to the side to simplify, and then solve it the same way we were solving before. B. Jumps right out at us that there's fractions. So I have 3 things to say about fractions. Now, I don't think we've really done any solving equations with fractions yet. Sometimes we do that as part of like the review at the beginning of the course, but we didn't do those days. So we haven't seen this yet, but you've seen it in other years for sure. Okay, I got 3 things to say about fractions. 1, so students are scared of fractions, or people are scared of fractions, not even just students, people are scared of fractions, right? And so they get this like reaction when they see a question with fractions, like, oh no, fractions, I hate fractions. Well, first of all, calculators these days will do all the fraction math for you. So that's one reason not to be scared of fractions, right? Just punch it into your calculator. I don't need to see your fraction math. I don't need to see you getting common denominators and that sort of thing. So no reason to be scared of fractions. Get yourself a calculator that can do fractions and learn how to do fractions on a calculator. That's one thing. 2, fractions aren't actually that hard. You have to take my word for it because we're not really going to work on fractions in this course. They're not that hard, but they're just less familiar. You just haven't practiced with fractions as much. When you started adding or subtracting or multiplying, dividing, whatever, and you started doing integers in elementary school, I think they start doing integers, so negative numbers in grade 7, it seems really hard because it's so different. And then you practice them enough that you get good at them. Fractions is the same. The problem is we don't practice them enough. And we don't get good at them unless you end up with a job where you have to use fractions. But it's like anything. If you do it enough, it just becomes, easy. But we haven't done it enough, so it's not easy to do it in our head, and that's fine. Like I said, we can use our calculator. But the third thing is, fractions in equations aren't really doing fraction math. Because when you have fractions in equations, we're actually just the first thing we're gonna do is get rid of the fractions. So I call this like a three small step sort of thing that we do when we see an equation with fractions. The first thing is we have to pick a number. And we have to pick the right number. Okay? And we'll talk about what the number is, and probably a lot of you already know what it is for this question. So we pick a number. What do we do with that number? We multiply everything by that number. What does that accomplish? It gets rid of the fractions. So there's your three steps. Pick a number, multiply by the number, get rid of your fractions. So if you're scared of fractions, you hate fractions, you don't like fractions, no problem. We're going to get rid of them anyway. And then we're going to have an equation that we're familiar with, that looks normal, and that we can solve the regular way. So how do I pick the number? Who knows what the number is that I'm looking for here? Like, what's your gut tell you? Any thoughts? 6. So we haven't even talked about what the number, like what the point of the number is. I didn't give any instruction into what the number should be like, and yet 6. Yes, very good. So what we are probably looking for is the lowest common denominator. So some number that's a multiple of all the denominators. So what's the smallest number that's a multiple of both 3 and 2? And it's 6. So that's the number we're looking for. Could you use 12? Yes. If you use 12, then when we go to factor or solve it, however we solve it, we're going to have a common factor. If you use a bigger number, you're just going to end up with a common factor. And if you just factor it out, then it's no big deal. If you notice that. You're going to end up with bigger numbers, which can be harder to work with, but it's not necessarily wrong. Okay? But if you pick the smallest one, it's going to make your life a little bit easier. So we're going to multiply through by 6, and this is how I'm going to show it. I'm going to say 6 times x squared over 3 minus 6 times x over 2 minus 6 times 3 over 2. And although this is a relatively straightforward process, once you get that number and once you remember or know what you're supposed to do with the number, which is multiply everything by that number, once you get that, it's a fairly straightforward process, but there are little mistakes that people make. Like they forget that you also have to multiply the other side by the number. Sometimes people think that if you have any term, any number that's not a fraction, then you don't have to multiply that number by 6 in this case. Well, it's not a fraction, I don't have to do anything to it. No, the point is you have to multiply everything by 6 to keep your equation balanced, right? Everything on the left times 6, everything on the right times 6. So you do have to multiply everything, whether it's a fraction or not. That's one of the tricks. And then another one is sometimes people come up with a number like bigger than 6 for a reason. We won't get into it too much, but again, like I said, that won't, if you went with 12 or 18 or 24, you wouldn't be wrong. You're just making your life a bit harder. Okay, but this is the biggest mistake, is people don't multiply the other side by your common denominator, or even if I have a number on the left side that's not a fraction, they think they don't have to multiply that kind of thing. Okay, and then what happens when I multiply? Well, this is like 6 divided by 3. 6 divided by 3 is 2. 6 divided by 2 is 3. 6 divided by 2 is 3. So for every term that has a denominator, that has a fraction, I'm taking that number that I picked, 6 in this case, and dividing by the bottom of the fraction, right? 6 divided by 3. And it should get rid of all the denominators. If for some reason it doesn't divide evenly, like if I had a 4 in the bottom, well, 6 divided by 4 is not going to work. So that means I picked the wrong number. Okay, so it should always work. Our fractions are all the way gone. And I get 2 times x squared minus 3 times x minus 3 times 3. And 6 times 0 is 0. You do not have to write that step out the way I wrote it. Sometimes it might be useful to. The reason I wrote it is just to show what this next step looks like. Right? This means whatever's left times what's in the bracket. So 2 times x squared. That's what that means. So that's why I wrote it out this way, just to show that. But you would probably just multiply it and get, okay, so it's 2x squared minus 3x minus 9. Okay. And now, this question has nothing to do with fractions. Doesn't matter how it started, doesn't matter that it had fractions at one point. It's just a regular trinomial. It's simplified. Everything's on the left side. It's equal to 0. So I'm going to check b squared minus 4ac. In this case, it's 81. So we can factor again. Again, I've got a prime. 2 is a prime, so I know it's going to be 2x and 1x. And I'm going to guess that it's 3 and 3. For 9, it's either 1 and 9 or 3 and 3. I'm going to guess it's 3 and 3. And sure enough, I've got 6x and 3x, which gives me 3x. I want the 6 to be negative and the 3 to be positive, because the middle term is negative. So I've got x is negative 3 over 2 and positive 3. All right, a couple more. If I can find it. There it is. Okay, so what jumps out at us about this one? It's got decimals. Decimals are just numbers, kind of like fractions. We got a couple of options, one way or another. The first thing I'm going to do is I'm going to move everything to the left side. So 0.4x squared. I'm going to subtract 2.1x. So minus 2.1x. And I'm going to subtract 4, so minus 4. two options. One is similar to the fractions, where I can choose a number to multiply by that will get rid of the decimals. And again, a lot of you probably already know what that number would be. It's going to be some multiple of 10. By that I mean it's going to be 10 or 100. Some power of 10, I should say, not really a multiple of 10. Power of 10. 10 or 100 or 1,000 or 10,000 or whatever. Not usually that big. And the number that I multiply by has to have the same number of zeros as the maximum number of decimal places that I have. So in this case, both my numbers only have one decimal place. So I can multiply by 10. I'm not going to write it out like last time where I do 10 times this, 10 times this, 10 times this, 10 times this. That is what you're doing. You have to multiply everything by 10. But the point is, we're doing this because we know what's going to happen when we multiply by 10. I know that it's going to bump the decimal places over. So I end up with 4x squared minus 21x. And yes, I have to multiply the negative 4 by 10 as well. Even though it's not a decimal, I'm multiplying everything by 10. So minus 40. And I even multiply the 0 by 10. That doesn't do anything. But we are still doing that. I'm multiplying by 10 on the left, so I have to multiply by 10 on the right. But I still get 0. Now, you don't have to do this. It's kind of up to you. It depends on the circumstance. In some cases, it might be useful. In some cases, it might be a waste of time. Because I could do two things. I could have just said A was 0.4, B was negative 2.1, and C was negative 4. And I could do B squared minus 4AC on that. So, negative 2.1 squared minus 4 times 0.4 times negative 4. 10.81. Then we're going to ask, is that a perfect square? Well, perfect squares with decimals, again, is not something we're as familiar with. So you may not know. You may not be able to tell. I could just take the square root of it and see what I get. And I got some nasty decimal. So I can guess, nope, that's not a perfect square. Or you might just use a quadratic formula because why not? You're already this far in. I'll just not even worry about whether this is factorable. I'll just use quadratic formula. Or if I did clear the decimals, then I do this. A is 4, B is negative 21, and C is negative 40. And I do B squared minus 4AC on that. And you can see how those answers are related. But again, if I do the square root of that, nope, I get a decimal. So either way, I'm using quadratic formula. And really, the quadratic formula is just about as easy with decimals as it is with whole numbers. So that's why, you know, you might do that or you might not. It's good to know how to clear out decimals. So that's why we talk about it. But you don't have to. You could have just left it like that and solved it with the quadratic formula. I suppose if the question said solve by factoring, then you would have to. I'm not going to ask that on the test. Another teacher might. Then you would have to know how to clear the decimal. But for this class, we don't have to. Roman, you had your hand up? No. You're good? All right. So we are using the quadratic formula. b is negative 21, so 21 plus minus the square root of 1081 over 2a. Make sure that you don't use a combination of the whole numbers and the decimals, right? I'm using the whole numbers as opposed to using the decimals, so I got to make sure I use all of those. Don't mix and match. And when I punch these in, you know what, we might as well just do it. So I get 21 minus 1081. It's a really good idea that you make sure, you don't have to do it right now, but at some point, make sure that you can punch this into your calculator properly. We talk about this, but whether your calculator, you require brackets or it does fractions nicely or whatever, however you're going to do it, that you practice doing it, and it's good to do it for a question that we've done together so you know what you're supposed to get, and you know what it's supposed to look like. Okay, and once I've done one, I just get in there and change it to a plus to do the other. We good? We're going to do one more. If you look back at all four examples, there's kind of a point to every single one. The first one was simple distributive property. We've kind of done that already, but the second one was fractions, third one decimals, and this one is binomials. Now we have done some expanding of binomials, so again, and you would have done lots of it in grade 10, so this is not new, but it is a little bit different from the other examples that we've done so far. So I'm going to do the first one the long way, and I'm going to do the second one a shorter way, and again, you pick which way you're most comfortable with. Doing it the shorter way will save you one step of writing. If you can do it in your head, if you can do the mental math, save yourself a little bit of time. The long way is I do 2 times x and 2x times x and 2x times 5. So I get 2x squared plus 10x. Then I do negative 1 times x and negative 1 times 5 minus x minus 5. And those two middle terms are going to add together, and I get 2x squared plus 9x minus 5. The slightly faster way of doing it is if you have really clicked with that pattern. The first term is going to be 3x times x, which is 3x squared. I know that the next two are both going to be x's, and they're going to add together. So instead of writing it down, I'm going to do that in my head. So I've got 3x times negative 2, which is negative 6x, plus 1x, which is negative 5x. And then 1 times negative 2 is negative 2. So if you think that that's doable, and if you get that pattern, you see that that happens every single time when we're doing these binomials, like I said, save yourself a step. But that's totally up to you. It is not worth skipping steps if you're going to get the wrong answer. It's not that much extra writing to write it out. And in a pinch, or like if there's something weird about the question, it's got fractions or decimals, or for whatever reason you're just not sure, and there's something, some kind of gut feeling you're having that something's wrong, do it the long way. Do it the careful way. That's how you can make sure that you're on the right track. Okay, then I move everything to one side, set it equal to 0, and solve. In this case, I'm going to move to the right. I almost never do this because I'm in the habit of putting everything on the left and having the right side equal 0. Why, in this case, would I move it to the left? Exactly right. I want my x squared to be positive. So if I subtract 2x squared from both sides, I get x squared. Negative 5 minus 9. Again, you can use your calculator to do this. Negative 5 minus 9 is negative 14. If you're not, like, even though this math is way harder than what you did in grade 7 with integers, for whatever reason, sometimes our brains just don't manipulate integers nicely. And we get confused when we're adding negatives or subtracting negatives. So negative 5 minus 9. You just type it out and just use your calculator. It only takes a second. Negative 2 plus 5. Because it's a negative 5, so I'm adding 5 is going to be plus 3. And I get 0 on this side. If I had done it the other way, I would have got this. Negative x squared plus 14x minus 3 equals 0. And you can see the relationship between those two. The green one, all of the signs are flipped compared to the blue one. And then again, I would take an extra step and I would change that to get the exact same thing in both cases, just the zero's in a different place. Okay. Either way, then I'm doing b squared minus 4ac. And I think in this case, somebody can check this to be sure, but I'm going to do this quickly so that we're done. I believe it works out to 184, so we're doing the quadratic formula again. Punch it into my calculator and get my 2 decimal answers.